We're going to start learning how to solve equations, and this is something that you may already know how to do, but it never hurts to review. And this is a one-step equation. And the reason it's called a one-step equation is because you can solve it in one step. So this equation says c minus 22 equals 54. And when you're solving any equation, what you want to do is find your variable, which in this case is c, and our goal is to do some math stuff. And after we do some math stuff, we want to end up with c equals a number. We want to end up with the c all by itself. And when you do this, this is called isolating the variable, which is a really fancy way of saying get the variable all by itself. So that we have the variable on one side of the equation and the number, which is the answer, on the other side of the equation. So this one is c minus 22 equals 54. Now what I notice about this equation is that if I got rid of this minus 22, like if this minus 22 was gone, if I just crossed this out, I would have the answer. I would have c equals 54. If I could just somehow get rid of that minus 22, I'd be done. I'd have c equals 54. But of course, it's not that simple. I can't just cross out a minus 22 just because it would make my life easier. But what I can do, another way I can get rid of minus 22, is I can add 22. So if I had c minus 22, and then I just put plus 22 equals 54. Now I have gotten rid of the minus 22. And the way that I've gotten rid of this is minus 22 plus 22 is 0. And so I'm left with just c. c equals, which was my goal, to get the c by itself. Now, hopefully what you're doing is you're looking at that and thinking, okay, sure, technically you got rid of the minus 22, but what you did is absolutely no different from just crossing out the minus 22. And you're right, I cannot just do plus 22 on the left side of this problem any more than I could just cross out the minus 22. I'm not allowed to do that unless I also do plus 22 over on the other side of the equation. If I do plus 22 over on the other side of the equation, now I have kept the equation balanced. In other words, what I have done on one side of the equation, I have also done on the other. And the reason I'm allowed to do this is because of a property called the addition property of equality. The addition property of equality says you can add anything you want to one side of an equation as long as you add the same amount to the other side of the equation. Well, 54 plus 22 is 76. So I believe the answer here is 76. Looks like 76 is the answer to me. There's a way I can check the answer though. Let's see if 76 is really the answer. My original equation was c minus 22 equals 54. I think that c equals 76. Let's find out by substituting 76 in place of c. So 76 minus 22 equals 54. Is that true? Is 76 minus 22 equal to 54? And the answer is yes, it is. 76 minus 22 is in fact 54. So the way that I solved this equation just now is what is called the horizontal method. And it's called the horizontal method because whenever I added 22 to both sides of this equation, I wrote it all in one line. I wrote it straight across from left to right. There is another method for solving this that you may be more familiar with called the vertical method. And I'm just going to real quick show you what this looks like because this is the method that you're more than likely going to use. I shouldn't even really call it a different method. It's not a different method, it's just a different way of writing it. But instead of adding 22 by putting it on the end of each side of the equation, you just write it underneath. And the reason you're more likely to use the vertical method than the horizontal method is because it takes up less space. I don't have to rewrite the equation when I add 22 to both sides. So negative 22 plus 22 again is 0, leaving me with c. and 54 plus 22 is 76. So I get the same answer both ways, but the vertical method is just a little more compact, takes up a little less space on the paper, and that's why that's more than likely going to be the method that we end up using whenever we solve these equations.